Okay, so the last video, this is where we left off. We had this in our graph. We got the zeros and the minimum points. So I'm going to go back to our Word document and draw this graph. So I'm going to first do the minimum, which is 1, -4. So over here, that minimum value was 1, 1, 2, -4, 1, -4. And then our zeros were -1, 0, and 3, 0. So I'll put a point at -1, 0, and 3, 0. Okay, so if I draw a graph here, let me Okay, so I'm going to draw a graph here. Goes through these points. Best that I can. There we go. Okay, and we want to know where x is -2 and x is 0. So if I go over to x is -2 right here, and I go up, it looks that our graph is about 4. Okay, and we can check that too back here on our graph. If we go to -2 and go up, it looks like right here it's going to be at 4. Okay, -2, 4. Alright, so there's that point there. That's where x equals -2. And I want where x equals 0. So here's 0. I go down. And it should be about at -3. And again, we can check back here. At 0, we go down and it crosses right here at -3. Okay, so we should do our best there with knowing that where x is 0, that's -3. And what this is telling us to do is to draw a line segment connecting those points. So from -2 to 0. Okay, so that's the highlighted part. I will draw in black as well. So -2 to 0. That black part, that's the line. So that's what we have to do for B. Now C says do the calculations in part B, so we just did, represent the average rate of change for the entire function, justify your reasoning. Right, so this part, this line we drew in part B, is that the average rate of change for this whole function? No, that's only the average rate of change where between x is -2 and x is 0. Right, so we're going to explain that here. No. That is the rate of change between -2 and 0 from part B. If we look at a different interval, right, if we went from maybe 1 to 3, that's going to have a different average rate of change. It's going up, so it's going to be totally different. Okay, so we could say something like that. Different intervals will have different rates of change. Okay, and that is how you justify your answer for this part. Don't just put no, make sure you explain that here. All right, last one, 15. The function below models the path of a projectile over time. Okay, so part A says determine the average rate of change, again the slope, m value, between 0 is less than or equal to x is less than or equal to 1. So between, here's our x. X is right between 0 and 1. Okay, so we're looking at this point between where our graph is at 1, which is right here. Right, so those 2 points is what we have to use to find our slope. The first point is 0, 0. 2 0 zeros from that point there. Our second point here is 1 all the way up to 1, comma 1,500.
It's huge.
Hi.
How are you?
Good. Okay, sorry about that. So 1, comma 1,500. That's our second point. Okay, so to find our m, rate average rate of change, so do the change in y's on top, which is 0 minus 1,500. So 0 minus 1,500 over the x's, which is 0 minus 1. And we can put that right into our calculator, 0 minus 1,500 over 0 minus 1. So I go over here. I'm going to go to the calculator, and I'm going to write a fraction. So 0 minus 1,500 over 0 minus 1. Enter, and we get 1,500. Back over here, this is equal to 1,500. And our label here is centimeters per second. So we're going to have centimeters per second. And that is our answer, 1,500 centimeters per second. Okay, B. Determine the average rate of change given the slope between 1 and less than equal to x, less than equal to 2. So this time I'm looking at from 1 to 2. So the point 1 is again that 1, comma 1,500. And where x is 2, that's this point up here, it's the point 2, comma 2,000. Okay, so to find our m, change in y over change in x, so our subtract our y, 1,500 minus 2,000. And then I do the x is 1 minus 2. And again, this can just be put right into our calculator. Let's line all the way across. As I go back and I do that, I hit a fraction button. And on the top, we have 1,500 minus 2,000. The denominator was 1 minus 2. Enter, we get 500. Over here, this is equal to, we'll write it down here, is equal to 500 centimeters per second. 500 centimeters per second. And then the last one here just says to interpret the meaning of the varying rates of change. Okay, so what this is saying is from 0 to 1 second, right, from 0 to 1 second, this half, this height of the ball is going up to 1,500. Okay, so from 0 to 1 seconds, the ball increases 1,500 centimeters every second. Okay, and similarly, right, from the other points we looked at, from 1 to 2 seconds, is x values, the ball increases, we found this 500 centimeters per every second. So our label was centimeters per second. Centimeters every second. Right, if we go back up, we can see as this ball is going to keep going up and up and up, it's slowing down a little bit. It's not going as fast. It's going 1,500 centimeters per second, but then it slows down until it gets to that max to 500 centimeters per second. Okay? It's slowing down as it gets to that max. Alright guys, go ahead and go on to target 4D video. Sorry this was so long.